All right, here we go. We're going to talk about section 7.3, which is talking about sample means. And let's get started with it. Okay, so we are looking at means. So we're looking at how we took a sample of 50 high school seniors at a small high school. So this is all the seniors in this high school. And here's the data. Not that I expect you to be writing this down or anything, but I just want to show you that what I've done is I've taken each student and given them a number. I number them 1 through 50. And then I'm just going to use a random integer generator on my calculator so I can get a simple random sample. So I'm going to select 5 students out of all of these, just based on what number my calculator generates. So I just wanted you to see where I'm getting the numbers from. Those 50 students, I've created a population distribution, so every student's height is listed on here. So each dot represents the height of one student. Okay, this one is a student who has a height of 188 centimeters. This was a student who is 140 centimeters tall. Now we want to make a guess at the mean. And I have the actual one already written in here. Sorry about that, but make a guess before I show you along with the standard deviation. And the actual one turns out to be 168.96, so approximately 169 centimeters. And our standard deviation is almost 10 centimeters. But what we want to do is take a simple random sample of 5 students and calculate the mean, and then repeat it for 4 more samples. So again, I generated random numbers from the calculator and then pulled those students' heights. So these were the first 5 students that I generated and the mean from them. Second set of 5 random students and the mean. Third sample, fourth sample. And again, I just calculated the mean based on those 5 students. I then created a dot plot from all of these sample means. So it's a sampling distribution of X bar. And we're using X bar here because we're talking about means. And it's a sampling distribution. Oops, let me slide this up. So same scale as we had up here for our population distribution. So here are all my points that I have, I think approximately 30 of them I pulled. And it's tedious, I totally agree. But each dot, remember, represents one sample of 5 students and their mean height. So this dot is the mean height of 5 students. This dot is the mean of a sample of 5 students and their height. If we had to describe the shape, the center, and the variability of this, the shape is approximately normal. Again, approximately, roughly symmetrical. It's better to say roughly symmetrical. We have a single peak right here around 169. Center is approximately 169, and the spread or the variability it's much smaller variability than our population. So our population went from 140 to like 188. Here it looks like we're about 164 to 178. So much smaller variability. And we know that the center for my population is going to be the same as the center for our sampling distribution. Likewise, the standard deviation of my sampling distribution I can find by taking the standard deviation of the population and divide by the square root of n. And n represents your sample size. So if I were to compare my sampling distribution to my population distribution, the shapes are similar, the centers are the same, but the second dot plot has much less variability. And the key fact here is that if the population distribution is approximately normal, so that was, again, the population, so each dot represented one individual, then the sampling distribution is also approximately normal. So that's going to be very key for us to be able to do these pieces. So the important learning targets here is that when I'm looking at a sampling distribution, my pen looks like it's dying, of X bar, The mean of the sampling distribution is the same as the mean of the population. The variability of my sampling distribution, and I designate that with the X bar, is equal to the standard deviation of the population divided by the square root of n. And make sure you remember it's a square root of n, not just n, but the square root. And the second learning target, the shape of the sampling distribution of X bar is approximately normal. Then we said that if the population is approximately normal, then the sampling distribution is also approximately normal. So it looks like this. We have to designate as normal using the mu of X bar, which is the same as mu of the population. The standard deviation, though, is the standard deviation of the population divided by the square root of n. And again, to find z then, I would use my X bar minus mu divided by the standard deviation. So standard deviation divided by square root of n. And of course, then I would go to my table and use that to find the probability. For the check your understanding, again, I encourage you to do this on your own. So pause this, and I do have a couple of comments after you finish it. So pause this, work through the 4 problems, or 4 parts, and then come back. Okay, so hopefully you've worked through this on your own. So here I've given the mu and standard deviation for a population, and now I want to take a sample. But I'm going to take a sample of just one teenager. Not a great sample size, but okay, we can still do that. So here's what the population looks like, my mean and standard deviation, and I'm going to calculate. And I'm looking for the probability of a teenager watching more than 25 minutes. So I want the right side of this. So again, anytime you're shading to the right, whatever your probability is, you have to subtract from 1. So I got my z-score of 1.23, which gives me a probability of 0.8907. I subtract that from 1, and this is the probability of a single randomly selected teenager watching more than 25 minutes in a given day. Okay, and as we keep going, now we're going to have a population of 10, a sample size of 10. And the thing I want you to make sure you see is down here, when we calculate our mean, we had 18.5, and the standard deviation for the sampling distribution, we divide by the square root of 10. So that is 1.676. That is a much smaller standard deviation than we had for the population. And we want to find the probability of the mean then we want to find, that the sample that we take, that mean is greater than 25 minutes. So notice that the shape of this is much more compressed, if you will, around 18. And when I go to calculate it, my probability is less than 0.002. So a very small probability in the sampling distribution of having a sample where the mean is greater than 25. Okay, and we will go on and do the second part of section 7.3.